Hi and welcome. I'm Brad Kuvin, Editorial Director of MetalForming magazine at the Precision MetalForming Association. And I'm pleased to be at Schuler today to speak with Jens Aspacher. Jens is the Senior Sales Manager for hydraulic presses at Schuler and is an expert in hot stamping technology. And we're here to talk to Jens today about some new hot stamping technology that Schuler has developed for stamping of aluminum. So welcome, Jens.
Welcome, Brad.
Yeah, thank you. Nice to see you. So this new process from Schuler, it's called FAST, right? So can you talk a little bit about the backstory of FAST technology and the initial drive for its development?
Yeah, of course. So we are actually since many years in contact with the Imperial College with Dr. Lilian Wang. And they have also developed the previous process, HFQ. And we were also looking at these results, but we were not really convinced. And so we were always following him because he told us that he has much more ideas to develop this process further. And so 1.5 years ago, he came up with his first results out of his research work in the laboratories in London. And he offered us this process on a small test rig in a very small scale. And from the theoretical point, it was very attractive. Yeah? But of course, for us, there was a question. I mean, we are a press manufacturer. We know how the equipment looks like. And we were really wondering how this could work in a press shop environment with a real aluminum part. Yeah? But I think this was the starting point then to work together, and we also found a third partner, which is a tier 1 supplier from China, company Hanlai, and they had a very much interest in developing this process. So we did the whole next developing steps together with the three parties. We rented some press equipment at the Automotive Center Südwestfalen in Germany, where we did all the trials, and so the results are what we're presenting now. Yeah.
Very good, very good. So compared to existing industry processes for hot forming of aluminum grades, what are the greatest benefits of this new process?
So I think the greatest benefit is that we could reduce the required equipment you need for the process dramatically. So due to this fast heating, which can be applied in the die, we don't need any furnace in front of the press. Yeah? So we can skip this furnace completely, replace it with a heating plate. And also because of the speed of the process and the happening in the microstructure of the aluminum, there is no post-treatment required. So we don't need more chamber furnaces for aging of the products because the tensile strength is still the same or nearly still the same like the incoming material. And so we can reduce footprint, investment, and also a lot of energy consumption, and I think this gives a very positive footprint, CO2 emission footprint for this product.
Okay, very good. So types of parts that you see being ideal for this process, and is it automotive specific, or are there other industries you think can use this technology?
I think a big part will be the automotive industry because the industry is a big consumer of aluminum in the market. But we are already in contact with some companies out of the aircraft industry. We also start to test the material which they normally use, 2024, which is different to the automotive grades. And the aircraft industry is looking for more efficient forming technologies because it's a lot of handcraft what they are making. Sure. And milling, and so with a huge consumption of material. So they are keen to develop this further. And I'm pretty sure that there will be other industries which we're not aware of yet, but maybe also this webinar could be start to show this to other industries, because always if you need high strength aluminum and to bring it in shape, then you need some heat support, and then this could be a possibility to use this process. Yeah.
The types of parts that are being made so far, then?
It's wide open. Yeah. Of course, we might be limited in size, because of the speed. If the parts are too big, then it's difficult to transport them in the speed we need to keep the technology, the microstructure in the right way. Yeah.
Gotcha. Okay. So then talk a little bit more about the cost savings as well as the energy savings. You talked about no furnace required. So what have you been able to document so far in terms of cost and energy savings?
So in the cost saving, of course, it's the press and it's the transfer and the automation around and the die with the heating plate. So it's, I would say, half or even less than half from the other equipment what is needed. But I think the big benefit is really the energy, which is required, and we stated or we always state about 80% savings in energy. These go back to the investigations of the Imperial College. Of course, we will, when we have our first production line running mid of this year in China, we will verify these numbers with production, because if you don't have a production, it's more or less calculation work you do to make the comparison, but it's with energy you can calculate very good what is ingoing. And I think this is the key for this process, that you can reduce the energy consumption, because that's today's topic is reduction of CO2 emission. Right. In all industries.
Yeah. All right, very good. Well, I think that wraps things up. Thank you so much for joining us today, and we'll look forward to seeing how this technology develops in the coming years.
Yeah, thank you very much as well, and have good times. Yeah.
Thank you.